Okay, let's go ahead and go over homework 15. So we're obviously trying to find the orders for these reactants. So 2, 1, 2. So first order with respect to the hydrogen. And then I can use, okay. 1, 2, 8. So third order with respect to the iodine. All right, so we got those. And then what's the overall reaction order? That would be 4. Just add those up. What would happen if I doubled both? Okay, so that's just a math problem. What do you need to do? Yep, just 2 to the 4th. You just add those things up and I'm doubling it. So that's why it's 2 and it's to the 4th because it's a 4th order reactant. So that's, what is that? 32, 16, 4, 8, 16. And that's how the overall order is helpful. You can just, well, what happens if I double everything? How much faster will it go? And just, that to whatever the overall order is for its power. Okay, same thing again. Twice as big here, same size there, twice as big here. All right, so first order with respect to the nitrite, and then 1 there, 2 there. All right, so that was easy. First order with respect to both the nitrite and the ammonium. That was the whole question. Alrighty then. Determine the order for each. So another order problem. So here first, double. So it's first order with respect to the oxygen. All right, let's pick here, doubling here, 1 there, and this goes up by 4. So second order with respect to the nitrogen monoxide. And I guess that's all I'm asking you for. All right. So reaction mechanism, what do you guys have for that one?
Just a diagram showing how how the molecules collide, how that turns into what the end reaction is, or the end product.
So you have a visual representation of how the molecules actually run into each other and then what their products are, how they react to produce what you come up with. I think I said this before when we were talking about mechanisms, but if you take organic chemistry, half the class is you going through reaction mechanisms to understand what product is going to be made and why that product will be made. All right, so relate the 4 factors affecting to the 3 parts of the collision theory. Okay, so collision theory, they collide. They have a certain amount of energy and orientation. There's a certain orientation associated with this. Okay, so the 4 factors that affect the rate of the reaction are nature. Why do I have state in a parentheses? Why do we call it the nature of the reactants instead of simply just the state of the reactants? Yeah, a lot of it has to do with surface area. So one of the reactants might be a solid, like that's just the way it is. So you can obviously affect the rate of the reaction by increasing the surface area by grinding it. So if it's a powder, it reacts more quickly than if it's, one solid chunk. Okay, so depending on what state it's in or the nature of that solid state, you're going to have the reaction happen faster because more of the reactant is available to run into more things. If it's just a surface area thing, then the surface reacts. I mean, you've seen tractors and things out in cars in the forest and they've been there for decades. And they're not completely gone because all that's happening is the surface is getting corroded. And then something has to agitate that surface to get the rust to fall off before you can access new iron. So nature is about collision and then concentration. If you remember from solutions, this brackets around anything is about moles per liter of whatever you put in there. So the concentration, I increase the concentration, they're more likely to run into each other. I decrease the concentration, the reaction slows down because they're less likely to run into each other. Energy is about what? As far as the 4 factors go?
About whether or not there's enough energy to make the.
Yep.
To make the reaction.
But what's the? It's about temp.
Yep.
So if I increase the temp, then I increase the energy. And since the reaction has to initially break bonds before I can initiate new bonds being formed, the higher energy allows the bonds that are there already to be broken more easily. And then the last one is orientation is about what?
Catalyst.
So if I have a catalyst, that catalyst has the ability to orient the reactants. So when they run into each other, they run into each other correctly. All right, that's all I got. Let's kill